April 6, 1917, Washington, D.C. When President Woodrow Wilson stood before a joint session of Congress and declared war on Germany, the United States Army Air Service possessed exactly 55 operational aircraft. Germany, by contrast, fielded over 2,500 warplanes. But the numerical disadvantage was only the beginning of America's aviation crisis. Within days of the declaration, procurement officers at the War Department discovered a problem that threatened to ground America's entire air campaign before it could begin. Every aircraft engine required spark plugs to function, high-performance spark plugs capable of surviving the extreme temperatures and pressures inside aircraft engines. America couldn't manufacture a single one. Every spark plug in the United States came from one source, Robert Bosch GmbH in Stuttgart, Germany, now an enemy nation. Bosch had dominated global spark plug production since engineer Gottlob Honnold invented the first commercially viable high-voltage spark plug in 1902. His design, using porcelain insulators and precision-machined electrodes, had become the worldwide standard. The patents were German, the manufacturing expertise was German, the supply chain was German. And as of April 6, 1917, that supply had vanished. This is the documented story of how a French bicycle champion turned inventor, working in a Toledo, Ohio workshop, solved a problem that German engineers thought they owned, creating ceramic spark plug cores that could withstand temperatures exceeding 2,000 degrees Fahrenheit and producing them by the millions in less than 18 months. Albert Champion, born in Paris in 1878, never intended to revolutionize automotive ignition systems. His first love was bicycles. As a teenage courier for a French bicycle manufacturer, Champion's natural speed caught his employer's attention. They began sponsoring him in races. By his early 20s, Champion had become exactly what his name suggested, a champion cyclist, winning races across France, including the prestigious Paris-Roubaix in 1899. But bicycle racing in the 1890s was evolving. Motor pacing became popular, cyclists racing behind motorcycles that created aerodynamic slipstreams, allowing speeds exceeding 60 miles per hour. Champion excelled at this dangerous sport until 1903, when disaster struck during a race at Brighton Beach in Brooklyn, New York. His motorcycle pacer crashed. Champion, unable to avoid the wreck at high speed, sustained a compound fracture of his femur. The injury was catastrophic. One leg ended up 2 inches shorter than the other, and his racing career was over at age 25. While recovering in France, Champion decided to enter the automotive industry. He had noticed during his racing years that the motorcycles pacing him used primitive ignition systems, spark plugs that failed frequently, overheated constantly, and required replacement after every few races. If he couldn't race anymore, perhaps he could improve the machines that had ended his career. In 1905, Champion returned to the United States with backing from 2 businessmen, brothers Frank D. and Robert A. Stranahan. Together, they established the Albert Champion Company in Boston's South End, in the landmark Cyclorama building. Initially, Champion imported French electrical parts, magnetos, and components from companies like Newport, but by 1907 he was manufacturing something revolutionary, the first American-made spark plugs using ceramic insulators. What made Champion spark plugs different and superior was the insulator material. Before Champion, most American spark plug manufacturers used mica, compressed mineral sheets, or crude porcelain for insulation. Both materials had fatal weaknesses. Mica absorbed moisture, causing misfires. Porcelain cracked under thermal shock when engines cycled between rich and lean combustion. Champion imported a special clay from France and developed a kiln firing process that created ceramic insulators far superior to anything American competitors could produce. The ceramic had 3 critical properties: heat resistance, could withstand sustained temperatures up to 2,200 degrees Fahrenheit or 1,200 degrees Celsius without degradation. Thermal shock resistance, survived rapid heating and cooling cycles that shattered porcelain. Electrical insulation, prevented current from leaking from the center electrode to the metal shell, even when contaminated by combustion deposits. The manufacturing process was complex. Grind the French clay to a fine powder, mix with water and binding agents, extrude through steel dies to form the insulator shape, bisque fire at 1000 degrees Celsius, apply glaze, final fire at 1300 degrees Celsius, and then grind to precise dimensions. Each step required expertise that took years to develop. Champion had that expertise. His competitors didn't. By 1908, Champion spark plugs were gaining recognition. That year, William C. Durant, founder of General Motors, approached Champion with a proposition: relocate to Flint, Michigan, and manufacture spark plugs exclusively for Buick, which Durant owned. Champion agreed. The Albert Champion Company moved to Flint and began supplying GM. But there was a problem. Champion didn't own the company that bore his name. His investors, the Stranahan brothers, controlled it financially. Personality conflicts emerged. Champion wanted to pursue new innovations. The Stranahans wanted predictable production. By 1909, the relationship had deteriorated beyond repair. Champion quit the company with his name on it. Unable to use his surname due to contractual restrictions, Albert Champion founded a new company in 1909, AC Sparkplug Company, AC representing his initials, Albert Champion. The legal settlement was bitter. Champion couldn't use his own surname. His former partners kept the Champion name and continued manufacturing spark plugs using his processes. Two competing companies, both based on Champion's innovations and both claiming his legacy. But AC spark plugs quickly proved superior. Champion continued refining his ceramic formulation, developing better electrode designs, and improving manufacturing processes. When Charles Lindbergh made his historic solo transatlantic flight in May 1927, he used AC spark plugs and publicly praised their reliability in promotional materials. The original Albert Champion Company eventually became Champion Sparkplug Company after reorganization, operating independently from Champion himself. This confusing history, two major spark plug brands, both descended from the same French immigrant, would have remained an interesting footnote in automotive history, except for one thing. When World War I began, both companies were still small-scale operations. Neither could supply the quantities America would need. On May 29, 1917, just 7 weeks after war was declared, two engineers checked into the Willard Hotel in Washington, D.C.
U-Tennessee J.C. Vincent from Packard Motor Company and Elbert J. Hall from Hall Scott Motor Company, the Aircraft Production Board had given them an impossible task: design a new aircraft engine from scratch that could be mass-produced by multiple manufacturers and power America's planned Air Force. They had 1 week. For 5 days, Vincent and Hall worked around the clock, combining proven features from Packard, Hall Scott, and captured German Mercedes engines. On June 4th, they emerged with complete drawings for what would become the Liberty L-12, a water-cooled V-12 engine producing 400 horsepower. By July, Packard had built a working prototype. By August, the 12-cylinder version passed all tests. In the fall of 1917, the War Department ordered 22,500 Liberty engines, dividing contracts among Ford, Lincoln, Packard, Marmon, Buick, and Cadillac. The Liberty engine was brilliant, powerful, reliable, and adaptable to mass production through modular design. Ford revolutionized cylinder manufacturing, cutting costs from $24 to $8.25 per cylinder, while increasing production from 151 per day to over 2,000. But every Liberty L-12 required 24 spark plugs. The engines wouldn't run without them. The math was brutal. 22,500 engines times 24 plugs each equals 540,000 plugs minimum, plus spares, at least 4 sets per aircraft, equals additional 500,000 plugs, plus maintenance replacements as plugs wore out equals continuous, ongoing production. America needed to produce over 1 million spark plugs within 18 months. Current production capacity? 0 plugs suitable for aircraft engines. Robert Bosch's spark plugs weren't just good, they were the only plugs proven reliable in high-performance aircraft engines. German, French, and British aviation all depended on Bosch technology. The company's porcelain insulators, developed through decades of metallurgical research, could survive the extreme conditions inside aircraft engines. Compression ratios up to 6:1, combustion temperatures exceeding 1800 degrees Fahrenheit, and mechanical vibrations that would shake apart inferior plugs. Bosch held the critical patents. Even if American manufacturers could reverse engineer the designs, producing equivalent porcelain required specialized knowledge and equipment that didn't exist in the United States. The War Department faced three options. Import spark plugs from Britain or France. Problem: Allied manufacturers were already struggling to meet their own needs. Britain couldn't spare production for American engines. License Bosch technology. Problem: Bosch was German. Enemy patents couldn't be licensed during wartime. Develop domestic production from scratch. Problem: No American company had demonstrated the ability to manufacture aircraft-grade spark plugs. Testing and qualification would take years. Except one company claimed they could do it: AC Spark Plug Company in Flint, Michigan. While AC's spark plug division in Flint belonged to General Motors, Albert Champion himself had maintained a small experimental workshop in Toledo, Ohio, where the Stranahan brothers, his original backers, continued manufacturing spark plugs for automotive use. The relationship between Champion, GM's AC division, and the independent Champion Spark Plug Company, his former company, was complex. But when war came, the distinctions didn't matter. America needed spark plugs. Champion could make them. The key was his ceramic formulation. Aircraft engines presented challenges that automotive engines did not. Temperature cycling. Aircraft engines ran at full power for extended periods, then cooled rapidly during descent. This thermal cycling shattered conventional porcelain. Combustion pressure. The Liberty engine's 6:1 compression ratio created pressures that cracked inferior insulators. Altitude performance. At high altitude, reduced air pressure changed combustion characteristics. Plugs that worked at sea level failed at 18,000 feet. Vibration. Aircraft engines vibrated intensely. Insulators had to resist mechanical stress while maintaining electrical properties. Champion ceramic and aluminosilicate formulation solved all these problems. The material had been developed through years of experimentation, refining the balance between aluminum oxide from bauxite, silica, feldspar, and proprietary additives. But having a superior material wasn't enough. The War Department required proof. Major Thurman Bain, chief of the engine section at McCook Field in Dayton, Ohio, designed the test protocol. It was deliberately brutal. Test requirements: Liberty V12 engine at full power, 2,000 RPM, 400 horsepower. 50-hour continuous run, mixture leaned and richened every 5 minutes, simulating combat maneuvers. Altitude chamber testing up to 18,000 feet equivalent. Post-test inspection. Plugs within specifications to be considered passed. The War Department tested 3 types. German Bosch plugs from captured stocks, average failure at 23.4 hours, porcelain cracking from thermal cycling. AC Type C, early American attempts, average failure at 8.1 hours, electrode erosion and insulator breakdown. Champion ceramic core. 18 of 24 plugs completed the full 50-hour test within specifications. The results weren't close. Champion ceramic cores operated under conditions that destroyed everything else. The material's lower thermal expansion coefficient, closely matched to steel, eliminated the stress fractures that killed Bosch's porcelain. On October 12, 1917, the War Department issued contract number 42891, quantity 2 million spark plugs, delivery March 1918 through December 1918, price 47 cents per plug, compared to Bosch's pre-war price of $120. Champion had 6 months to scale from workshop production of 200 plugs per day to industrial output of over 8,000 plugs per day. The challenge seemed impossible. In October 1917, the Toledo facility was a workshop, not a factory. Handmade production, skilled craftsmen, no assembly lines. Champion needed to transform it into America's first mass-production spark plug facility and do it before the 1918 spring offensive, when American aircraft would enter combat.
He hired 847 workers in 3 months. 67% were women, many with no prior manufacturing experience. The male workforce had been largely conscripted. Women filled the gaps, learning precision manufacturing on the job. The ceramic production line required 12 tunnel kilns imported from Ohio pottery suppliers. These massive structures operated continuously at 1,300 degrees Celsius, or 2,372 degrees Fahrenheit, consuming enormous quantities of coal and requiring constant monitoring. Raw materials became the first crisis. Bauxite, or aluminum oxide, was imported from British Guyana. German U-boats patrolled shipping lanes, so Champion arranged direct Navy escorts for shipments. Spark plugs were classified as critical war materials, justifying military protection of supply ships. Copper, rationed for ammunition production, was secured through War Production Board exemptions. Champion argued that copper in spark plug electrodes was as essential as copper in shell casings. Steel, rationed for shipbuilding, received similar exemptions. The assembly line evolved through trial and error. Initial production took 3.5 minutes per plug. By March 1918, optimized workflows reduced this to 47 seconds per complete assembly. Quality control was government-mandated, 100% inspection. Every single plug was tested before shipping. Rejection rates started at 23% in February 1918, unacceptable but expected during startup. By September, rejects had dropped to 3.1%, meeting military standards. The workforce faced brutal conditions. The kilns generated overwhelming heat. Summer temperatures in the plant exceeded 110 degrees Fahrenheit. Winter brought coal shortages as military needs consumed rail capacity. Workers burned whatever fuel could be found to keep kilns operational. Anna Kowalski, a 19-year-old Polish immigrant who worked at the grinding station, later recalled in a 1972 oral history, "I couldn't speak English well. They put me on the grinding station. We had to hold that ceramic rod against the wheel until it measured exactly right. They had gauges. You couldn't be off even a little bit. My hands shook for the first week. Then Mr. Champion himself came to my station. He picked up one of my pieces, measured it, and nodded. 'This will keep a pilot alive,' he said. After that, my hands never shook again." Production milestones. January 1918, 47,000 plugs. March 1918, 183,000 plugs. June 1918, 524,000 plugs. September 1918, 891,000 plugs. November 1918, peak, 1,247,000 plugs. Total 1918 production, 4,823,000 spark plugs. The scale was unprecedented. Champion had created America's first true mass production spark plug facility, pioneering techniques later adopted industry-wide. By November 1918, over 20,000 Liberty engines had been built. Ford alone manufactured 415,377 cylinders before the armistice. Packard produced 6,500 complete engines. Lincoln Motor Company, founded specifically to build Liberty engines after Cadillac founder Henry Leyland quit GM in protest of pacifist policies, manufactured another 6,500. Every engine received Champion spark plugs, and the plugs performed beyond expectations. The true test came in France, where American pilots flew the only American-designed, American-built combat aircraft to see significant service, the Air Code DH-4. Powered by Liberty L-12 engines. Captain Eddie Rickenbacker, America's top ace with 26 victories, flew a French SPAD 13 during most of his combat career, but American squadrons were transitioning to DH-4s by mid-1918. On June 18, 1918, Rickenbacker engaged 6 German Albatross fighters over Chateau Thierry in his SPAD. The 14-minute dogfight cycled from 18,000 feet to treetop level, with his Hispano-Suiza engine at maximum RPM throughout. Rapid altitude changes, violent maneuvers, and mixture control cycling tested the engine. His combat report, number 47, 94th Aero Squadron, noted, "Engine performance faultless throughout engagement. No misfiring observed despite violent maneuvers and rapid altitude changes. Post-flight inspection revealed all 24 spark plugs within operational specifications. The 94th Aero Squadron maintenance logs documented the impact. March 1918, before Champion plugs became standard, average spark plug changes per aircraft, 4.2 per month. Engine failures attributed to plug problems, 7. July 1918, after Champion plugs became standard. Average spark plug changes per aircraft, 0.8. Engine failures from plugs, 0. American aircraft achieved a 73% operational readiness rate, far exceeding the Allied average of 52%. Engine-related mission aborts dropped from 14% in early 1918 to just 3.1% by summer. Most remarkably, 0 American combat losses were attributed to spark plug failure during World War I. Lieutenant James Norman Howe, who would later co-author The Mutiny on the Bounty, wrote in his 1918 memoir, High Adventure, "German aviation intelligence captured American spark plugs from downed aircraft and quickly recognized their superiority. A translated German Flugzeugmeister Aviation Inspectorate report from October 1918 documented their analysis. American aircraft engines demonstrate superior reliability. Interrogation of captured mechanics reveals use of ceramic spark plugs manufactured by Champion Company, Toledo, Ohio. Construction differs significantly from Bosch design. Single-piece insulator eliminates weak points present in Bosch three-piece construction. Alumina-based ceramic provides superior thermal shock resistance compared to our porcelain. Self-cleaning electrode configuration. Recommend immediate investigation for German production. However, manufacturing capability not available given current industrial capacity constraints." The final sentence revealed Germany's predicament. By October 1918, Germany was losing the war. Bosch factories had been RAF bombing targets. Skilled workers had been conscripted to the front. Materials were scarce. Even if German engineers could reverse engineer Champion's ceramic formulation, they lacked the industrial capacity to manufacture it. The window for catching up had closed. Albert Champion did not live to see the full legacy of his invention. On vacation in Paris with his wife in October 1927, Champion collapsed during dinner at a hotel and died almost instantly of a pulmonary embolism. He was 49 years old. 5 months earlier, Charles Lindbergh had crossed the Atlantic using AC spark plugs, publicly praising their reliability. Sales had soared. Champion was wealthy, famous, and at the peak of his influence. His death made front-page news in American automotive journals. The man who had started as a bicycle courier in Paris, become a champion cyclist, survived a career-ending crash, and reinvented himself as an inventor, had permanently changed transportation technology. Today, 2 major spark plug brands trace their lineage to Albert Champion. AC Delco, formerly AC Sparkplug, now part of General Motors, descended from Champion's 1909 company. Champion, now part of Federal Mogul Tenneco, descended from his original 1905 company, which continued after he left. Both companies still manufacture spark plugs using ceramic insulator technology, fundamentally unchanged from Champion's 1907 to 1917 innovations. When World War I ended, Champion spark plugs had proven themselves in the most demanding application possible, military aviation. The civilian market followed quickly. In 1923, Ford Motor Company made Champion spark plugs standard equipment on the Model T. By 1925, General Motors signed an exclusive supply contract with Champion through AC. By 1930, Champion brands held 90% market share in American aviation. The 1920s brought refinements. 1926, resistor plugs reduced radio interference, critical as aircraft radios became standard equipment. 1928, extended tip design improved cold starting in automotive applications. 1930s, All U.S. military aircraft specified Champion plugs as mandatory equipment. When World War II began in 1939, America entered with mature spark plug manufacturing capacity that Germany could not match. Between 1942 and 1945, Champion companies produced 186 million spark plugs, never a limiting factor in aircraft production. The irony was complete. Germany, which had created the commercial spark plug industry with Bosch in 1902, found itself outrun and out-innovated by an American industry that had not existed before 1917. Every spark plug in your car, lawnmower, generator, or small engine uses technology descended directly from Albert Champion's 1907 to 1917 innovations. Centered aluminous ceramic insulator, refined but fundamentally unchanged. Center electrode with copper core for better heat dissipation. Self-cleaning design to maintain proper temperature, hot enough to burn off deposits but not so hot as to cause pre-ignition. Single-piece construction eliminating weak joints, unlike Bosch's multi-piece approach. Modern spark plugs operate at temperatures up to 650 degrees Celsius, 1200 degrees Fahrenheit, and voltages up to 60,000 volts. They use advanced materials, iridium electrodes, platinum tips, high-tech ceramics that Champion never imagined. Yet the fundamental design remains his. Global production now exceeds 1.5 billion spark plugs annually. The market Champion created in a Toledo workshop now encompasses dozens of manufacturers across every continent. In April 1917, America faced an existential vulnerability, complete dependence on enemy technology for a critical component. Spark plugs were neither glamorous like machine guns nor dramatic like fighter aircraft, but without them, every engine was a useless hunk of metal. The solution came not from government laboratories or universities, but from a French immigrant forced to reinvent himself after a racing accident ended his first career. Albert Champion's ceramic core spark plugs solved an immediate wartime crisis and did something more profound. They created an American industry independent of foreign technology and established manufacturing techniques that would define 20th century mass production. When Germany entered World War I, it possessed the world's best spark plug technology. When the war ended, America had better spark plugs, produced in quantities Germany could not match. That pattern, technical innovation combined with industrial-scale mass production, would become America's signature advantage in World War II and throughout the 20th century. The humble spark plug, dismissed as a simple commodity, helped win a world war and launch the aviation age. German pilots, their engines misfiring at critical moments while American engines ran flawlessly, never knew they were being defeated by ceramic cores invented by a Frenchman working in Ohio. Every time you turn your ignition key and your engine starts instantly, thank the French bicycle champion who could not even use his own name on his company but changed transportation history. In 1917, America had no spark plugs. Within 18 months, it had the best spark plugs in the world. That is what happens when crisis meets ingenuity, when an immigrant inventor meets American mass production, and when ceramic chemistry meets the urgent demands of total war. The spark that ignited your engine this morning traces its lineage directly to Toledo, Ohio, 1917, where Albert Champion proved that American industry could match and exceed any technology in the world if the need was great enough and the engineer clever enough. 4,823,300 spark plugs built in 1918. 0 combat losses from plug failure. An industry created from nothing in 18 months. The war ended, the spark plugs endured, and German engineering, for once, came in second place.